Good day everyone. Today we are taking the third impossible construction, that of squaring a circle. What does that mean? Well, the impossible construction, we know it means that in mathematics a construction is only with these tools, a compass and a ruler, but not like this with marks on it, an unmarked ruler, so you cannot measure anything, you can draw a line. Now it has been proved that squaring a circle is not possible with these two tools only. Then what are we going to do? We are going to add some more things in it besides these two tools, some method, some model and so on, and ultimately construct a square which is equivalent to a circle. And what do we mean by that now? It means that given a circle, you know its radius, circumference, area and so on. If we want to convert a square into a circle, a circle into a square, it means you have to construct a square now whose area is the same as that of the given circle. That is the job at hand right now, and this is what we do. The models that we shall be using, or the parts of the model, there is a strip here. It is for support. So this is the strip. Now we have a circle. This is the given circle. And we shall say that we can take the radius as r. We cannot measure it, but whatever it is some r units. Or we can say that whatever is your radius, we'll call 1 unit. We'll say that the radius is 1 unit here, whatever r. It may be 3.5 inches or 7.9 centimeters, whatever it is. We'll call it 1 unit. Okay, now what we are going to do is, here is a circle and I have marked on it this line here, and directly opposite to it, diametrically opposite to it, I have marked another line here. So these two are diametrically opposite. This is half the circle and that is half the circle. And therefore, if this is the whole is 2 pi r, and since we are taking r equal to 1, the whole is 2 pi. So if you take only the semicircle, this or that, the length will be pi. That is what we are going to use now, and this is how we are going to use it. We'll start with any one of the 2 points here at the end, and as I told you, this is our supporting strip. On that we shall roll. And what shall we roll? We shall roll this circle without sliding. That means it should not slide like this. It should roll without sliding. And so you will see we have reached here. The other point that we had marked opposite to the first starting point, and we have made a mark here on the support strip. So we rolled our circle along this, like this, and we ended up here. And therefore, as you can see, what happens is that every point here comes in contact here with the strip, and therefore on this line we have exactly pi when we reach here. I did not do just now properly because we have done it once. Now after taking this pi, we do one more thing. This radius we have called 1 unit, you may call it r units, whatever. We take, mark on this strip a point which is 1 unit or r, whatever units from this mark which we have for pi, and that we take by taking tangent to this circle, and you can see that it will be equal to the radius. Okay, so now we have 2 marks on this. One is pi, the other is 1. Okay, now the next thing to be done is, on this length, pi plus 1, take the midpoint draw a semicircle, and here is the semicircle. From the starting point to pi plus 1. At the point pi, the mark for pi, we take a perpendicular. And how do we take a perpendicular? As we just saw just now, like this. Now this is a right angle, so I will take this as the perpendicular. At the point for pi, I have taken a perpendicular and it cuts the semicircle at this point. And what we now claim is that this length is the required root pi. And therefore, if you construct a square on it, it will be root pi into root pi. The area will be pi, which is precisely the area of our circle, pi r square, where r is 1. Okay, now if you take r, you will have r throughout and it will work out the same way. Now, we cannot stop here and say that, okay, here is root pi and here is the square that you wanted. We have to prove that this is the required square, or in other words, this length is root pi. And in order to prove that, we shall draw here. As you know, we rolled the circle and got pi here. Then we took 1. This was pi, this was 1, and on that we took a semicircle. We took the midpoint and took the semicircle. At this point where we had pi, the mark for pi, we take a perpendicular. That's what we have done here with this red one. This is our red line and this is our red square. And we claim that this x is equal to root pi. And now we want to prove it. And in order to prove, we can see that this is a right angle. Why? Because it is angled in the semicircle. So this is a right triangle in which x is the altitude upon the hypotenuse, and therefore x squared will be equal to the product of the two segments. In other words, x squared will be equal to pi into 1, or that will imply that x is equal to root pi. Well, that's what we wanted. This is our x here, that is root pi. We have taken a square with side root pi, therefore its area is pi, which is precisely the area of the circle with which we start. So that's how we construct a circle, a square whose area is equal to the given square, or what comes down to, it boils down to construction of root pi. This x equal to root pi, construction of root pi. Okay, thank you.